The lesson topic for this video is using shortcuts to graph radical functions. Okay, so here is our standard form of our radical function for square roots. And so far we know this is a square root function. And remember that without a number right in here, it's a square root. And that's all we'll be dealing with in this unit. We know the graph is a curve. And that curve, again, can go up and to the right. That curve could go up and to the left. That curve could go down to the right, or it could go down to the left. So there's a lot of different ways the curve can go. And the starting point we know is HK. So those are some basics of radical functions so far. Now you might have been wondering, well, what about A? And we're going to talk a little bit more about what A does, as well as one other thing that can happen that will help us see more of the graphs that go left and down instead of the one that we've been seeing the most of. Okay, so here are four radical equations. This first one you should be recognizing as our parent function, y equals the square root of x. Each of the other three equations show something just slightly different from the parent function. This one has a negative under the square root before the x or x minus h. This one shows an a value of 3, and this one shows an a value of negative 3. So let's graph these in different colors and see what happens. All right, so our first one is our parent function, and we're going to put 0 in for x right here. We're going to put a 0 in. Well, what's the square root of 0? We know that that is 0. So our first point is at 0, 0. And I'm going to use a slightly larger dot when I put that on my graph. All right, so there it is. Close anyways. Okay, and then we are going to put in a 4 for x. We're going to put in a 4. So the square root of 4 is 2. Our second point, therefore, is 4, 2. So 4 comma 2 is right about there. Oh, not graphing dots very well. Okay, so if I were to graph the line or curve from there, it would be like this. Now let's see what happens when we try this blue equation right here. So y equals the square root of negative x. First of all, if we put a 0 in here, we have negative 0. Well, negative 0 is 0, and the square root of 0 is 0. So we still start at 0, 0. Now you might be thinking, I thought we couldn't have a negative under the square root. Well, and that's kind of true, but let's think about this. If I put a 4 right here for x, if I put a 4 in for x, I would get the square root of negative 4. Well, we can't do that. The square root of negative 4 doesn't exist. So yes, it's true that we can't have a negative under the square root, but what happens if I made this 4 instead of positive 4? What if I made it negative 4? So let's just, all right, there we go. So if I put a negative 4 in for x right here, what would happen is I would have the square root of negative 4. What's a negative 4? Well, it's positive 4. So we'd have the square root of positive 4, which is 2. So our second point for the blue line is at negative 4, 2. So here's our original or starting point, 0, 0. And now we're going to go to negative 4, 2. So that's right there. And we are going to graph our curve. And what do you notice? Well, you should notice that if the parent function starts at 0, 0 and goes off to the right like this, then the parent function with a negative in the root starts at that same starting point, but curves to the left. It's exactly the same curve, it's just going to the left. So that should give you some information about what happens if there is a negative in front of the x minus h in our root. That means it's going to go left. Okay, so let's check this one. What happens when our a value is a number other than 1? Remember, there's a 1 right here in our parent function, but now it's a 3. So we're going to go ahead and put in a 0 for x right here. Well, the square root of 0 is 0, and 3 times 0 is 0. So we still have 0, 0 for our first starting point on this one. So I'll put a 0, 0 with purple. Now, let's go ahead and put 4 in again. Let's put in a 4. And when we put a 4 in for our into our root for x, we get the square root of 4, which is 2. And then we have 3 times 2, so that is 6. So we have 4, 6. All right, let's put that point on our coordinate plane. 4, comma 6 is right here. So that means our curve for this equation right here is starting at 0, 0 and is curving up like so. So again, comparing this purple curve to our parent function, what does this, the only change that's made between this equation and this equation, the only change that's made is the 1 is now a 3. So what does it do? Well, it makes the curve wider. So instead of a narrower curve, it makes the curve wider. Okay. One more. Y equals -3 times the square root of x. So again, we're still have the square root of x, not negative x, or that would mean if there was a negative in the root, it would be going left, but there's not a negative in the root, so it's going right. And let's find out what -3 does. So again, we'll put a 0 in first for x, so the square root of 0 is 0, and -3 times 0 is 0. So this one, again, starts at 0, 0. So now we've got a green dot on top of all the other dots for our starting point. And now we will go ahead and put in another value for x. We can put in +4 because we can take the square root of +4. The square root of 4 is 2, and -3 times 2 is -6. So now we can plot that point at 4, -6, which is right here. And that means our curve is going like this. Oops, not very good. I'm going to redo that. I don't know if you can even see it if I try again. There we go. So that curve is starting here and it's curving down and to the right. So it looks just like this purple one, but it's going down. It looks similar to the red one in that it's curving like an exponent, like a radical function, but it's going down and it's wider. Why would this be down and wider? Well, it's wider because of the 3, and it's going down because of this negative. So now we know that having a number out in front of the root makes it wider, a specific type of number. We'll talk about that in a minute. We know that a negative under the square root right here means it's going to go left. And a negative in front of the a value makes it go curve down. We will summarize this on one of the following slides. Okay, so let's look at one more thing that happens. Here's still our parent function, y equals the square root of x. I put 0 in and got 0. I put 4 in for x and I got 2. I plotted that, and here is my parent function graph. No different than what we've been seeing previously. So this time, the only thing that's different about the parent function to this equation is that a is a half. So let's find out what happens when a is a half. We still put in a 0 first for x here, and the square root of 0 is 0. 1/2 times 0 is 0. So we still have 0, 0 as our starting point. Put that right there on top of, whoops, the other blue dot, 0, 0. And now we are going to put in another value for x. Let's put in 4. So if we put in 4, we still get the square root of 4 is 2, and half of 2 is 1. Half of 2 is 1. So we get 4, 1. So now if I put a dot at 4, 1, it's right there, which means that when we graph this curve, it's actually going to be more narrow. Oops, that's not a very good one. I'm going to do it again. There we go. It is more narrow than our blue parent function. It's more narrow. Remember, when we had a 3 out here, it was wider. But when it's a half, it's more narrow. So that's what happens when a is between 0 and 1. So if it's a fraction between 0 and 1, it's going to be more narrow. Again, remember, if it's negative, it's going to go down. If it's greater than 1, it's going to be wider. But if it's between 0 and 1, it is going to be more narrow. Okay, here's that summarization of what we were learning, and I have 2 quick examples on the next screen that shows us what these shortcuts will do for us. We won't have to use a table to graph, we're just going to use the shortcuts. So we know HK is the starting point. If you have questions on that, let me know. Now about A. Okay, so this tells us the starting point, HK. If A has 3 different things that can happen. It can be negative, it can be larger than 1, and it can be between 0 and 1. If A is negative, remember the curve will go down. It'll curve down. Okay? If A is larger than 1, like the equation where A was 3 times the square root of x, that means the curve will be wider or more wide than the parent function. And if A is between 0 and 1, like the 1/2 on the previous screen, it will be more narrow than the parent function. And lastly, if there is a negative in the root before x minus h, remember the curve will go left. So those are our key pieces of information when we graph using shortcuts. Okay, so now we are going to use these shortcuts to graph these 2 equations without even using a table of values. They are going to be a rough sketch. They might not be like exactly on the right points, but that is all we're looking for by using these shortcuts. Okay, so this first one, we know a few things. We know HK, we know A, and we can graph it using what we just learned. So let's start by writing our HK. Go ahead and write that in. Hopefully you wrote -5, -8. Those come from right here again, x plus 5 means -5 goes here, and -8 means -8 goes here. Our A value is 1, 1/2, pardon me. A value is 1/2. Remember that because it's positive, it's going to be going up, and because it's 1/2, it's a little more narrow than the parent function. Okay? Also notice that inside the root, we do not have a negative in the inside of the root, which means it's not going left, which means it's going right. So again, a positive under the root means it's going right. We can put a little arrow here. We know it's going right. And because this is positive 1/2, we know it's going up. It's curving up. So we're going to put a point at -5, -8. It's right about here. And we know we're going to curve up and right at a little more narrow than the parent function. So we're going to just go ahead and do our best on this like so. And there it is. By the way, if you hear a little trombone in the background, that is my son. All right, next question. Again, we know the starting point. Write it in. It should be -3, 2. We know the A value is -1. So let's look at that. The fact that it's negative tells us this is going to, whoops, let's not do that, sorry. Because this is negative, I know it's going to be going down instead of up, right? It's going down because that A is negative. This right here, this negative right here tells us it's going to be going left. And because this A value is not greater than 1 or less than 1, it is just 1, it's exactly the same narrowness or wideness as the parent function, the regular parent function. So now we graph -3, 2 is right here. And it's going to be curving down, down, and left. And so it's going to be curving at the parent function rate. So it's something like that. So that's just a quick sketch. Let me know if you have questions.